So for testing and for cures for DMD, this is probably for me the most interesting part of this talk and the interesting aspects of this disease, because there's a number of factors that come into play that make this so tricky. From a testing point of view, there's actually quite a few options available. You can do just standard genetic testing. You can even test from in an RNA, MRI. You can do blood testing, muscle biopsy. So there's all sorts of things that can be done to test relatively easily. And obviously, because it's an inherited disorder that's so serious, if you knew about it in your family bloodline, you would almost be asking those kind of questions for people potentially looking to have children. Which jumps us on to potential cures and current research. And here is the problem. I mentioned earlier that the muscular dystrophy gene is big. It's really big. It's huge. And I'm going to touch on one of the aspects later, but from a gene therapy point of view, the gene is so large that it means there's an awful lot of DNA or RNA that you would need to pack into a virus vector if you wanted to do gene therapy. So there's a two-pronged problem with this disease. The first one is that the effects of dystrophin are distributed throughout your body, and therefore gene therapy is going to need to reach all parts of your body to help cure it, which is problematic. And secondly, the gene is so big that we need to find a vehicle big enough to support it. And a lot of the research for gene therapy uses an AAV virus, but it needs to be big enough to be able to take all of this gene information. So there are some other areas of research that we're looking at, and one of them that I think is interesting is to go down what's known as an exon skipping route. So the idea here is that we get, instead of reading the whole code wrong and creating a protein that's wrong, we do some work and make us jump over these areas that are wrong and create a protein that is definitely smaller, but is missing the wrong parts and still works. So the idea here is it's almost like saying, if someone was reading a book, to say to them, listen, don't worry about pages 68 to 74, just skip past and I'll let you know what happens. So exon skipping is one of the areas that's being explored. There's also a few drugs that have been pushed through on the market in the last couple of years. They've got complicated names like Exondys 51 is one of them, and Emflaza. But really, these drugs that are coming onto the market, they're not that effective. They only affect a percentage of people that suffer, but they're not curing it. They're alleviating some of the symptoms. So one of them is a corticosteroid, which will obviously slow down the rate of muscular degeneration. And the other one has an effect on this exon area, but it only works on about 1% of people, so it's not exactly hugely effective, but it's a start. So there's a two-prong approach here. One, alleviate symptoms. Two, try and find a way of curing things in the long term. Which kind of brings the whole talk together into a final bit as to why this disease has such an affiliation for me. In 1996, 1997, which is an incredibly long time ago now, I was lucky enough to do a year out in industry as a sandwich year with my degree and work at the Sanger Centre, which has changed names about 1 million times. But it's the Glaxo Wellcome SmithKline Sanger Centre in Cambridge. And I worked in the Human Genome Project, and particularly in the mouse sequencing laboratory. And in that laboratory, we worked on transgenic mice, which were specifically bred to look into muscular dystrophy. So again, like all things in science, the more we dig, the more complicated it becomes. And in fact, this gene for DMD is so big that there's actually 4 different regions where different errors can occur. And so we did a lot of research to understand those mechanisms a little bit better with a potential genetic cure. So I spent quite a lot of work with a team working on this, so it's nice to see some progress, but it's also a little bit dispiriting to think that we're nearly 25 years further down the line and we're still not at a genetic cure. Because I certainly remember when we worked on it, we were pretty convinced by 2005, 2010, this would be a completely curable disease. So there you go. That's kind of a summary of Duchenne's muscular dystrophy. So I've gone through a quick overview of the disease itself. We've talked about the symptoms, the molecular basis for what some of the issues are and how complex it is. And we've also looked at some of the potential areas for research and alleviation of symptoms and a potential long-term cure. But it's one of those diseases that's complex, and there are factors like its size and the fact that it's body-wide that are going to make this a particularly difficult disease to cure. And yet, as a genetic disease, it's the most prevalent in males because of the nature of the disease. So there you go. I hope you enjoyed my talk. I hope you enjoyed my little websitey bits. I'm sorry I couldn't be there. And hopefully I'll get to see all your other talks as well.